വെൽക്കം ടു ദ നെക്സ്റ്റ് സെഷൻ ഓൺ ഇൻഫിനിറ്റ് സീരീസ്. ഈ സെഷനിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യുന്ന ടോപ്പിക്ക് കൺവേർജൻസ് ഓഫ് പി സീരീസ്. അപ്പോൾ എന്താണ് പി സീരീസ് എന്ന് നമുക്ക് ആദ്യം അറിയണം. പി സീരീസ് എന്ന് വെച്ചാൽ ഇറ്റ് ഈസ് എ സീരീസ് ഓഫ് ദ ഫോം സിഗ്മ n equal to 1 to infinity 1 by n raised to p, which is equal to 1 by 1 raised to p plus 1 by 2 raised to p plus 1 by 3 raised to p plus etc. The series is known as a p series. Here p is a constant. So we can say that a 2 series is sigma n equal to 1 to infinity 1 by n square. That means 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus etc. And 1 by 2 series is sigma n equal to 1 to infinity 1 by n raised to 1 by 2, which is 1 by root 1 plus 1 by root 2 plus 1 by root 3 plus etc. Now let's check when a p series will be convergent. So the theorem says that a p series sigma n equal to 1 to infinity 1 by n raised to p is convergent if p is greater than 1 and divergent if p less than or equal to 1. So it's enough to look at p. A p greater than 1 ആകുമ്പോഴെല്ലാം p series convergent ആയിരിക്കും. Less than or equal to 1 ആണെങ്കിൽ divergent ആയിരിക്കും. So when p is equal to 1, what happens? P equal to 1 means the p series will become sigma n equal to 1 to infinity 1 by n raised to 1, which is sigma 1 by n, which is our harmonic series, and we know that a harmonic series is divergent. Now let's prove this theorem. To prove the theorem, we will take two cases. First, we will assume that p not equal to 1. So we will use integral test to prove this theorem. I am taking f of x as 1 by x raised to p, where x is an element of 1 infinity. So we know that this function f is continuous because ഇത് discontinuous ആവുന്ന പോയിന്റ് x equal to 0 ആണ്, and we are not taking 0 in our domain. It is positive because x പോസിറ്റീവ് ആണ്, so x power p പോസിറ്റീവ് ആണ്, അതുകൊണ്ട് അതിൻ്റെ റെസിപ്രോക്കൽ പോസിറ്റീവ് ആണ്. And it is decreasing. Why? x വലുതാകും തോറും ഡിനോമിനേറ്റർ വലുതായിക്കൊണ്ടിരിക്കുകയാണ്, so overall it will be decreasing. So we can apply integral test. Now I am taking p equal to 1. Then integral 1 to infinity 1 by x raised to p dx will be integral 1 to infinity 1 by x dx. Okay, which is equal to limit b tends to infinity integral 1 to b 1 by x dx. And integral of 1 by x is log x, so this will be limit b tends to infinity log x between limits 1 to b, which is limit b tends to infinity log b minus log 1. Okay, so as b tends to infinity, log b will go to infinity, so that this is equal to infinity. So when p is equal to 1, integral 1 to infinity 1 by x raised to p dx is divergent, and which implies that summation n equal to 1 to infinity 1 by n raised to p diverges if p is equal to 1. Okay, now let's take p not equal to 1. If p not equal to 1, then integral 1 to infinity 1 by x raised to p dx is equal to limit b tends to infinity integral 1 to b 1 by x raised to p dx. Now what is 1 by x raised to p? 1 by x raised to p is x raised to minus p. So if you integrate x raised to minus p, you will get x raised to minus p plus 1 divided by minus p plus 1. Okay, so we can write this as x raised to 1 minus p divided by 1 minus p. So let's check. This is equal to limit b tends to infinity 1 by 1 minus p into 1 by x raised to p minus 1. X raised to 1 minus p is same as 1 by x raised to p minus 1 between limits 1 to b. So 1 by 1 minus p is a constant, you can take it outside. So limit b tends to infinity, 1 by 1 minus p into, when you give the value x equal to b, you will get 1 by b raised to p minus 1 minus, when you give 1, it is 1 itself. So this is limit b tends to infinity, 1 by 1 minus p into 1 by b power p minus 1 minus 1. And its value will be, suppose p is greater than 1. So p minus 1 is greater than 0. So here we have 1 by b power p minus 1. So this b has a positive power now. When p is greater than 1, b has a positive power. When b goes to infinity, b power p minus 1 will also go to infinity. Okay, so that we can say that 1 by b power p minus 1 will go to 0 as b tends to infinity. Okay, so what remains is, in the limit we have 1 by 1 minus p, then 1 by b power p minus 1 will go to 0 minus 1. So minus 1 by 1 minus p. This is we have. Now if p is less than or equal to 1, what happens? If p less than 1, p not equal to 1 anyway, so p less than 1. P less than 1 means p minus 1 is less than 0. So the power of b power p minus 1, here p minus 1 is negative. So actually b is in the denominator. Sorry, here already b is in the denominator. So when you give b power negative power, then b will appear in the numerator. So when b goes to infinity, this will also go to infinity. So if p less than 1, we have the limit as infinity. Okay, so when p is greater than 1, we have a finite limit. When p is less than 1, we have an infinite limit. So integral 1 to infinity 1 by x raised to p dx converges if p greater than 1 and diverges if p less than or equal to 1. Equivalently, we can say that summation n equal to 1 to infinity 1 by n raised to p converges if p greater than 1 and diverges if p less than or equal to 1. Okay, this is about convergence of p series. Now ഇതെങ്ങനെ നമുക്ക് അപ്ലൈ ചെയ്യാം, എത്രത്തോളം നമുക്കിത് ഉപയോഗപ്പെടും എന്നുള്ളത് നമുക്ക് നോക്കാം. So here is a problem. Determine whether sigma n equal to 1 to infinity 1 by n square converges or diverges. So നമുക്ക് കണ്ടാൽ തന്നെ അറിയാം, ഈ സിഗ്മ n equal to 1 to infinity 1 by n square എന്ന് പറയുന്നത് ഒരു p series ആണ് with p is equal to 2. If p is equal to 2, it is greater than 1. Now p സീരീസിൻ്റെ കൺവേർജൻസ് എന്താണ് പറയുന്നത്? എ p series sigma 1 by n raised to p converges if p greater than 1. So here p is equal to 2, it is greater than 1, so this series will converge. So sigma n equal to 1 to infinity 1 by n square converges. And if you have any doubt in this, you can simply apply integral test and prove this result. Now sigma n equal to 1 to infinity 1 by root n, whether the series is convergent or divergent. Again 1 by root of n can be written as 1 by n power 1 by 2. So this is also a p series with p as 1 by 2 and 1 by 2 is less than 1. And the convergence of p series says that a p series sigma 1 by n raised to p converges if p greater than 1 and diverges if p less than or equal to 1. Here p is equal to 1 by 2, it is less than 1. therefore this P series will diverge. Okay, this is not convergent, this is divergent. Now the next problem, determine whether sigma n equal to 1 to infinity n power minus 1.001 converges or diverges. So n power minus 1.001 can be written as 1 by n power 1.001. So this is a P series with P is equal to 1.001. It is greater than 1, and if P is greater than 1, the P series sigma 1 by n raised to P converges. So this the given series is convergent. So നമുക്ക് പാർഷ്യൽ സീക്വൻസ് ഓഫ് പാർഷ്യൽ സം കണ്ടുപിടിക്കേണ്ട, വേറെ ഒരു ടെസ്റ്റുകളോ അപ്ലൈ ചെയ്യേണ്ട. പി സീരീസ് ആണെങ്കിൽ ജസ്റ്റ് ലുക്ക് അറ്റ് പി, വെദർ പി ഈസ് ഗ്രേറ്റർ ദാൻ 1 ഓർ ലെസ് ദാൻ ഓർ ഈക്വൽ ടു 1. പി ഗ്രേറ്റർ ദാൻ 1 ആണെങ്കിൽ വി ക്യാൻ കൺക്ലൂഡ് ദാറ്റ് സീരീസ് ഇസ് കൺവേർജൻറ്റ്, അതർവൈസ് ഇറ്റ് ഇസ് ഡൈവേർജൻറ്റ്. ഓക്കെ, അപ്പോൾ വളരെ ഇഫക്റ്റീവ് ആയിട്ടുള്ള ഒരു ടെസ്റ്റാണിത്. എല്ലാത്തിനും ഉപയോഗിക്കാൻ പറ്റില്ല, പി സീരീസുകൾക്ക് മാത്രമേ നമുക്കിത് ഉപയോഗിക്കാൻ പറ്റുള്ളൂ. അപ്പോൾ വീണ്ടും പുതിയ ടെസ്റ്റുകളുമായിട്ട് നമുക്ക്